Hi, I'm Peter Bryn. I'm with Volta Hydrogen. We are a green ammonia producer with production in Chile.
Peter, your paper at the MAP Americas conference generated a lot of interest. There was particular interest in the fact you have this Chile link. Tell us a little bit more about the company vision and why Chile.
Sure. So Volta Hydrogen is actually spinning out of a company called Distributed Power Partners. And Distributed Power Partners, or DPP, was created to install solar facilities in Chile and has been doing so for about 8 or 9 years. Chile is very interesting from a renewable energy perspective because it has the world's best solar in the north and among the world's best wind in the south. And what that world-class solar resource does is it gives us access to literally the cheapest solar power on the planet. The challenge is that for really since forever, that power has been stranded. There's been no way to get it out, and there's a relatively small population there. What producing ammonia from that power does is it allows us to export that energy all around the world and to use it in different industries, including, for example, the maritime industry, which is trying to decarbonize, where ammonia is emerging as arguably the best chemical solution as a replacement for heavy fuel oil.
Now, you say that ammonia is emerging as a solution, but at the same time, there are barriers to ammonia's widespread adoption, not least the production costs, the supply chain issues, the challenges of ramping up ammonia, and of course, the development of ammonia specific regulations.
Indeed, yeah. I mean, the adoption of ammonia certainly, or frankly, of any or any zero emission fuel, certainly has challenges going forward. The challenges for ammonia are probably most obvious on board the vessel and for ship owners and operators because of its toxicity, which is a serious issue that needs to be managed properly. Because of its lack of a bunkering infrastructure right now, of course, that has to be built out. So yeah, there are definitely steps that need to be taken. The reason that we're so bullish on ammonia is if we look from a well to wake perspective. So starting at the well, meaning production, then to distribution, then on board the vessel where we actually store it and handle it, and then at the end, the well, or excuse me, the wake, meaning converting that fuel into propulsion. So if you look across that entire value chain, the place where ammonia really shines is particularly upstream of the vessel, meaning when you produce it and when you distribute it. Production has probably the best potential of any al- alternative fuel to get the cost down. And the reason for that principally is because the ingredients for ammonia are quite simple. It's hydrogen, nitrogen. And hydrogen you're going to need for any alternative fuel. The nitrogen, the reason that's so attractive as opposed to a carbon-based fuel is it's a lot cheaper to pull nitrogen out of the atmosphere than carbon. So if you look at the cost curve potential for ammonia, it's quite strong and makes quite a compelling case. Now, of course, if you look downstream, if you look at the storage on board the vessel, that is arguably more challenging than something like methanol because of the toxicity issues. So we do recognize there's a real safety challenge here that has to be addressed. And then if you look at use of the ammonia in the engine, I think that's pretty comparable to any of the other fuels. So it's true that ammonia does have its challenges, particularly on board the vessel. But again, if you look from a well to wake perspective, in our view, overall, ammonia has the greatest potential, particularly on getting that cost curve down the quickest.
When you consider the use of ammonia as a marine fuel, to your mind, which propulsion technology is most efficient? Is it the conventional reciprocating engine, or are we talking fuel cells or something else?
Yeah, that's a great question. So the energy conversion device of choice, I think, is going to. I think the short answer is it's not going to change with ammonia as a fuel. And what I mean by that is if you have traditionally had slow speed diesel engines on board your vessel, which has, of course, traditionally been large ocean going cargo vessels, that's going to probably continue to make the most sense for your vessel. The cost to electrify those ships and the value add of fuel cells, it's hard to make that value proposition. The efficiency gain of fuel cells doesn't really appear to be there versus a slow speed engine where the efficiency is already quite high. So it's really all capital costs that would be incurred to electrify without really any obvious gains. So I think on those conventional vessels, you'll continue to see slow speed diesel engines. On vessels where you have traditionally had diesel electric propulsion plants, namely cruise ships, offshore installation vessels for wind farms and oil and gas applications like that, where you're electrified anyway, you do have the interesting opportunity to consider, instead of a reciprocating internal combustion engine, considering a fuel cell. And there are some interesting entrants into that space developing, particularly solid oxide fuel cells, which do potentially have some efficiency gains against diesel engines. So I think in those traditionally electrified sectors, you may see a mix of both. You might continue to see, Wärtsilä has been developing their ammonia engine for vessels in that space, and I think you'll continue to see that. You might see some fuel cells. And then on the smaller vessels, actually, to be honest, on the smaller vessels, meaning inland and coastal, that's where I do think ammonia may not find as much of a foothold. And the reason for that is because I think that the safety and handling challenges may start to overwhelm the capabilities of a small operator. So we might see it in those spaces, or we may see something like biofuels and methanol really being the fuel of choice for recreational boating, for inland towboats, for harbor tugs, things like that.
For those looking at adopting ammonia who are going to operate on conventional engines, surely for them there's no getting away from the need for a high percentage of pilot fuel, and also there's a lot of sort of talk and concern around possible ammonia slip.
Yeah, indeed. There are a number of questions around the engine performance itself, which, to be honest, I think right now is not well understood outside of the engine companies and perhaps a few of the universities also working on this. So I think the answer is we don't quite know yet what the ammonia slip, what the N2O emissions will be, and how much pilot fuel is needed. The good news, and in fact, this was something that was discussed at the MAP conference with one of the major engine manufacturers, is on all three of those fronts, the news seems to be preliminarily looking pretty good. From a pilot fuel perspective, there have been numbers floated around that I've heard range from as high as 30% down to 2%. I'm suspecting it's going to be closer to 2% just based on other engine needs, and also from what we heard from some of those manufacturers there. So there's the pilot fuel question. On the pilot fuel, I will point out that it's conventionally been thought of as, oh yeah, that's going to be diesel. It doesn't have to be diesel. You can take ammonia, you can crack it, have some hydrogen, use hydrogen. I mean, there's different ways to crack that nut. So so on the pilot fuel one, I think there is there's the potential that it's not going to be that significant, and certainly it looks like it's trending that way. On ammonia slip, I think we got similar kind of good news back that hasn't, and N2O on both of those issues in terms of the emission profile. It seemed like the preliminary feedback from the engine manufacturers that we got at the conference was, it seems like these aren't turning out to be issues as long as we can manage the pressures and timing correctly, which is certainly well within the capabilities of an electric timed engine.
Final question, and it's crystal ball time. What's the world going to look like 2030 and 2050 in this area?
Yeah, that's a great question. I mean, one of the key things that is needed in this industry is how do we get, especially in the near term, as there's a higher premium for these fuels than hopefully there will be in the future, how do we get that green premium covered? And it's all about cost, right? If we could produce these fuels today for, actually, with the increase in fuel prices recently, the delta, the green premium, has actually shrunk quite a bit from what it was, but because fuel prices have gone up so much. But so that the green premium is actually not quite as high as it was. But anyway, how do we get that green premium covered? Is it carbon fees? Is it voluntary action from the end customers? What are those mechanisms to do that? And the rapidity with which the industry moves to make those mechanisms available, including, for example, action by the EU to have the ETS include marine vessels, are important steps to get there. So I would say partly it's depending on the rapidity with which that happens. Partly it depends on the pace at which we can get the cost of these fuels down. And that's exactly what our company is working on, among others in the space. Just assuming that both of those things happen quickly, I think best case scenario by 2030, we are going to see a number of vessels operating that are capable of burning ammonia, capable of burning methanol and other fuels that are being considered. So I think we're going to see a number of them. It'll be a relatively small percentage of the overall fleet in terms of uptake and actual use of those fuels. Um, but interestingly, I mean, if you look at most of the forecasts that are out there, the balance of ammonia production that is expected to go to the maritime industry versus others in 2030, it's a very small percent as compared to where ammonia is going elsewhere in the world. By 2050, there are several pretty, respected industry forecasts that show that the maritime industry dominates the use of ammonia globally, and it really becomes aside from the traditional uses that we see it today, it becomes the main place where a lot of that ammonia goes. So hopefully that's the case. And hopefully by 2050, we have a fleet of, we get emissions down to zero, which is where we need to get.
And finally, Peter, reflecting on the conference, how did you find it?
Conference was a really interesting opportunity. I think it brought together some great folks in industry. Now, part of it, of course, was a little bit of COVID fatigue. It was just nice to see people out again and see people we hadn't seen in a few years. But also, a lot's happened in these past few years while we were all locked down in terms of engine technology, in terms of policy. And so this was, for me anyway, it was my first opportunity to see some of these folks again and meet some new people, see some new faces as well. Obviously, there was a big focus on the conference at sort of the what has traditionally been the focus on emissions, which is on sulfur and particulate matter. And the scrubber folks were there and talking about that technology. But of course, I was there looking more toward the future and saying, well, how do we really get to zero emissions? And that was kind of another set of conversations. So yeah, it was a great opportunity to connect with some large ship owners, to connect with the engine manufacturers, to connect with others in the space, and sort of see how others are seeing this transition.